Hi everyone. I want to take a moment to discuss the center of gravity approach to making a location decision. Now, this is an approach that takes into consideration that if you're trying to site a warehouse or a distribution center or a manufacturing plant, you want to take into consideration what are the different locations where you're going to be shipping product to from that central location, and how much product are you going to be shipping to the different destinations. Okay, so the center of gravity approach utilizes an XY plane to try and site the different locations for the different destinations within a given plane, and then tries to figure out for those different locations where would be the best possible location to site a plant or a distribution center. Okay, so if we are to visualize that, it would look something like this on a graph. Just use this space down here and assume we have an XY plane. Okay, so we have our X down here, we have our Y axis on the side here, and let's assume that we have multiple cities that we need to ship products to. So we could have, assume that these cities are on a geographic map. Okay, so we could have Chicago up here, we could have maybe St. Louis slightly lower, we could have Dallas, Texas somewhere there, and then maybe let's also throw in maybe Cleveland, Ohio somewhere there. Okay, now, and assuming that these four circles represent four different cities that we need to ship products to, we might want to know where is the centralmost position based off of both the distance and the total combined weights that need to ship to those cities. Okay, so we need to find a way to calculate what's the best possible location within which we should have a plant to be able to minimize cost, minimize distance, and provide the best possible service to all these four locations in this network. Okay, so the center of gravity approach utilizes the loads, okay, and it also utilizes the distances along the x-axis as well as the distance along the y-axis to make that the determination of where exactly would it make the most sense for us to place some distribution center in the network here, such that we have the lowest possible load distance to each and every place in the network. And we are in the process of doing that, satisfying both the needs to have highly efficient customer service and reduced lead times to get the products to those destinations, but at the same time reducing our total costs. Okay, so let's look at an example of how you'd go about using the center of gravity approach to answer a question. Okay, let's clear this drawing. And now let's go to, I believe we have an example here. So the example in the textbook reads that a supplier to the electric utility industry produces power generators. The transportation costs are high. One market area includes the lower part of the Great Lakes region and the upper portion of the southeastern region. More than 600,000 tons are to be shipped to 8 major customer locations as shown below. Okay, so a typical case that you might come across, we have to ship products to 8 locations. Where should we ship product from? Okay, so we know where product is going to go to, we just don't know where would be the best location in these states here where we should site our warehouses. Okay, so for us to do this, we need to know a couple of things. We need to know what's the total sum of all the different tonnages going to all the different locations. So I need to sum up our tons shipped to the different locations. And in addition to that, I need to know what's that sum total of, what's the combination of the amounts shipped from a given location to a given location multiplied by its length along the x-axis, and then the amounts shipped to a given location multiplied by the distance along the y-axis. Okay, So this will require that we let's do this in Excel because I find it much more convenient, and I'll do this by splitting our X into Y and then doing a few calculations with this extra columns that we have here. Okay, so the first calculation that I'll do is I want to split this information into the X's. So we have a 7, 8, 11, 12. No, I think I skipped one. 11, 12, 13, 14, 15. And here we have 13, 12, 10, 7, 4, 11, 10, and 5. Okay, so now that we have these here, one thing that I want to do is first of all figure out what's the total tons shipped to all 8 locations. Okay, so let's sum these up here at the bottom, and we come up with our denominator, which is 607,000. I'm going to use that in calculating the specific coordinates for our target destination. Okay, so we know our total tons shipped is 607,000, but I might want to know what's the tonnage that needs to go to Three Rivers, and I'm going to multiply this value here by the corresponding X value, and that'll give me a column that I'll call our LIX. Okay, so this will be 5,000 multiplied by 7, and I can drag the formula down for each and every destination we have here. And I'll also do the same for LIY, and I'm going to be multiplying the tons shipped by the distance along the Y plane or the Y axis. So this is multiplied by 13. Okay, so now once we've got these values here, I'm again going to calculate what's the sum totals for these two columns. So the sum total at the bottom here, you can use the sum function, calculate that, and also calculate the same for the last column here. Now that I have my information for the numerator and the information for the denominator, I will go ahead and divide that by our total tons shipped, and that will give us 750, that's what, 7.5 million divided by 607,000. And here I'm going to have this value here divided by 607 again. Okay, so that then gives us coordinate points, which becomes our X and Y value for that target destination or the target location where we need to site our warehouse. So the answer to this question then is what's the best possible location to site a warehouse? It's going to be at the coordinate 12.4 and 9.2. Okay, so if we site our location here, then we should have possibly the most efficient location to enable us to possibly minimize costs while maintaining a pretty good level of service to the different locations based off of what the tonnage is shipped here would be. Okay, and you notice that this value here is more closely aligned to the larger values that you have here when it comes to the tons shipped. Okay, that basically means that for your ultimate location, you want to be closer to those places where you have to ship a whole bunch of stuff than to those locations where you're going to be shipping very little. Okay, so it's better to be closer to wherever it is that you really have to ship a whole bunch of stuff than it is to be right in the dead center of the different destinations that you have here. Okay, so that's your center of gravity approach to finding out what's the best possible location to site a plant, to site a warehouse or a distribution center. Okay, I'll stop this here.